Hi, welcome to my channel. I am Abdurrahman Magdi and I will be talking about statics. We will start our first lecture by some basic concepts. They are basic concepts, but they are really, really important to our understanding of the course. So please pay attention. You might feel that it is a little bit boring, but this is really essential. Let's start by those basic concepts. The first concept I want to talk about is what we call the particle. One is particle. What is actually a particle? So a particle is actually has a mass, it has a mass but negligible size. You might ask, what does this mean? Particle with a mass but negligible size. It is a negligible size compared to something much bigger. For example, we have our beautiful Earth here, and Earth is huge, as you understand. So this is our Earth, for example, here we have our Earth, and this Earth is actually rotating or around the Sun, and the Sun is much bigger than our Earth. So this is our Sun, and the Sun is much bigger than our Earth. And this Earth is rotating around. Now, we can, at that case, because Earth is small in size compared to the Sun, we can neglect the size of the Earth and we can just consider it as a small, a small particle moving around the Sun. Okay, so this is the particle. I hope that it is clear. What is the second concept I want you to understand is the rigid body. A rigid body. What is a rigid body? If you understand what a rigid body is, you will actually understand so many things. A rigid body is a combination of particles. So the first thing that you need to understand about rigid body is that it is a combination of particles. But this is actually not the only thing. The only thing is that the particles are those particles are equi sorry, not equi, they are always, the particles remain fixed relative to each other, relative to each other. Okay, what does this mean? Please, I want to understand what does this mean. Okay, rigid body. A rigid body like this one, this is a rigid body. It is a combination of particles, as we said. And the distance between these two particles will remain the same. For example, this particle here, we have this particle A, and this particle here B. The distance between these two particles will remain the same no matter if you applied here a force, you applied here some like 1 to 6 Newton, which is a very big force. It doesn't matter. The distance between A and B will remain the same. So a rigid body is a combination of particles, and the distance between the particles will remain the same. That's what we call a rigid body. That's why we call it rigid. It does not deform. Okay, what is our third concept that we need to understand is the concentrated force. Concentrated force. What is a concentrated force? It is the effect of a loading uh, that is acted on a point of a body. If this is your body, for example, a rigid body, and you have here some point, and you have a loading acted on that. This loading could be, for example, a weight. You just put a heavy thing on that body, and it can be also a load if we have, for example, here a car. This is just a car, and this car is moving like that, and it has some luggage on the car. So these are loads acting on, we can consider them as concentrated loads acting on my car. So if I have, for example, a weight like that acting on, for example, let's say a bridge or something like that, this is just a bridge, and this is a load. The load is just a force acting. We can replace this distributed load by just a concentrated force. So the concentrated force acts on a point on the body, acts on a point on the body. So those are the three concepts. The particle, it has mass but has no, or it has negligible size. The second thing is the rigid body. A rigid body, we said that it is a combination of particles. And the third thing is the concentrated force. The concentrated force. Those are the three concepts that I hope that you understand. Okay, now let's take the Newton's law. Newton's laws, and those are really important if we are trying to study the statics. Okay, what is the first law? First law, and please be patient with me. This is really important, and we need to write it. We need to write it to understand what's going on. I'm sorry, this will be a little bit long, but please be here with me. Okay, a particle, what is the first law says? A particle originally, at rest or moving in a straight line, in a straight line with constant velocity. Okay, tend to remain in this state provided the particle is not subjected to unbalanced forces. Okay, so this has actually four things. This is the first thing. This is the second part. The second part, and here is the third part, and here is the fourth. Now let us understand that well. A particle originally at rest. Okay, so if it is originally at rest or moving in a straight line with constant velocity, so it could be moving but with constant velocity, will remain at this state provided that it is not subjected to unbalanced forces. So if it is subjected to balanced forces, if it is subjected to balanced forces, it will remain at its state. Okay, and this is really important for statics. So, for example, if I have here a particle and this particle is at rest, so it will remain at rest. Nothing will happen to that. If this particle is moving to the right with an acceleration of 0 meter per second square, so it is not accelerating, and with a speed of 5 meter per second, so it will remain at this 5 meter per second. It will not change, so the speed will not change. And this particle that is acted on by two balanced forces, if I have here, this is a force 1 equal to 5 Newton, for example, and force 2 is equal to 5 Newton as well. So this particle also, if it is moving at an acceleration of 0 meter per second and the velocity of 5 meter per second, it will remain moving at 5 meter per second. Okay, so either it is at rest or it is moving with a constant velocity, so it's not accelerating, the acceleration is 0, or it is acted on by imbalanced force, it will remain in this state. I hope that is clear. So this is the first law. Okay, let's now take the second law. The second law. Second law, it says that a body will be acted on by a force, it will accelerate in the same direction of that force. So, for example, that should be easy law. For example, if I have here a cart, for example, let's say this is a cart on the ground like that, and this cart was acted on by a force equal to, okay, it's just a force, okay, random, let's say this is just a random force, and the mass of the cart here is m, for example. So this force will accelerate the cart by some acceleration a. What is the relation between these three quantities? We can say that it is force equals to ma. And force has a direction and the acceleration has the same direction. So the force and acceleration will be in the same direction. This is the second law of, and this equation is really important. This is really important. What is the third law? Third law is very easy. It is about the action and the reaction. So if we have a force like that, an action will produce a reaction which is equal in magnitude but opposite in direction. So this is equal in magnitude but opposite in direction. This should be easy. Those are the three laws that are very easy. Now let's take one of the law, the Newton's law of gravity. Newton's law of gravity. What is the Newton's law of gravity? If I have two bodies like that, one with m1 and the second one with m2, we or Newton noticed that there is a force between these two masses, and he found that this is the Newton's law, is G times m1, m2, the two forces, over the distance between them squared. So the distance between these two. Okay. So this distance r, so this is the force between the two bodies. It is a G, is a constant, m1 times m2 over r squared. And he found that G is equal to 66.73 times 10 to minus 12 meter cube per kilogram times centimeter squared, right? How did we find those units? I mean, this should be. Let's do that as an exercise. So this is my g here. What is g actually? G is what is multiplied comes here to the denominator, and the rest goes to the numerator. F r squared. Okay, what is F? F we said it is M times A. So it is kilogram times the mass, the unit is the mass times meter per second squared. Meter per second squared. Because this is the unit of acceleration. So this is, we are now done with the F. Okay, we are done with the F. What about the R? The R is just meter, so it is meter squared. And this is multiplied by those two here goes to the numerator. We are 1 over kilogram squared, right? Yes. So you can find that kilogram here will cancel this square here, and you remain with what? Meter cube, because meter square times m, meter cube over kilogram times second square. So this is from here to get this unit. Easy. Okay, so we know now that the force is equal to G m1 m2 over r squared. And by the way, this law you will find it also, and for example, the law of if you have two charges, what is the force between the two charges will be also here a constant times m1 times m2, the charge of the first one times the charge of the second particle over the distance between them. Okay, anyways, but now what happens on our Earth? So we said that F is equal to m times A, right? We said that before. So it shows that this acceleration on our Earth, so for example, if we have our Earth is big like that, and I am standing here, this is me here, and I have some mass of Magdi, my name is Magdi, mass of Magdi, and this is the mass of Earth, it's big. Okay, what is the force between us? What is my weight? Because my weight is a force that is attaching me to the earth. So it is basically a force, or call this force weight. It is my mass, the mass of Magdi here, times some acceleration. What is that acceleration then? What is that acceleration? By comparing these two, we can find that the acceleration is the g, because this is now my mass. This is the mass of my, because I am the first mass, right? So the second mass will be the mass of what? The mass of Earth. So the acceleration A should be g. What is remaining, right? So what is remaining is the acceleration. So it is g times mass of Earth over r r squared. And this acceleration we call it g. G is just g, the big G, times the mass of Earth over r squared. And this, we understand that this r will change, but we will take it at the sea level. So if we usually take it at the sea level with a 45 degree altitude. So this is equal, as we know, to 9.81 meter per second squared. Okay, so for example, my weight, if I am 100 kilograms, if I have 100 kilogram, I will multiply this 9.81 meters squared per second, and this is a kilogram. So my weight is 981 newton. So this is mud, the weight of mud. Okay, nice, very nice. I hope that this helps. Last thing, I want to make sure that during our course we will use the SI units. We will use the SI units, and should be the same for imperial units or other units. But for length, we have the time, we have the length, we have the mass. Those are the basic three units that we will use, and other units can be derived from those three. So the time, as you know, will be in seconds, the length will be in meters, and mass will be in kilogram. And if you want to put the force, if you want to put the force, then force is what is force? Force is equal to mass times acceleration, right? So what is mass? Mass is in kilogram times the acceleration is meter per second square. Meter per second square. So the force is kilogram times meter per second square. And in recognition of Newton, this genius guy, we said that okay, let's call that kilogram times meter per second square. Let's call it Newton, and we are done with that. With that, yeah. Okay, thank you. And next lecture, we will talk about the force. Sorry, what is that? So we will talk about force vectors. Okay, force vector. See you next lecture. Thank you.